In order for your computer to figure out which of your monitor's pixels should be what color at what time on your screen within a matter of milliseconds, it has to do a ton of calculations very, very quickly. In modern computers, this is accomplished by the graphics card, a term many are familiar with, but might not understand all that well. Now, a graphics card is like a smaller version of your entire computer, but one dedicated to the task of figuring out how to put images on your screen, particularly images that represent a three-dimensional world. Like your computer, the graphics card has its own processor inside of it, known as the GPU or graphics processing unit. The GPU is to your graphics card what the CPU is to your computer as a whole. The primary difference between a GPU and a CPU is in how many cores they have. The cores of a processor are like small calculators that can very quickly do the calculations required for your computer to think. A modern CPU usually has about 8 cores at least, while a modern graphics card has anywhere between 1,000 and 4,000 of them. Although a CPU has less cores, each core in the CPU is far more powerful than each one in the graphics card. This is because CPUs are used for things like logic and instructions, which can get very complicated. Even though these cores are more powerful, they can each only do one task at a time. Now, when you're talking about instructions, that's okay. But the individual tasks that are required for graphics rendering aren't really all that complicated, there's just a lot of them. So using a CPU to render graphics would result in all of the potential of those cores being wasted. We end up with all the tasks waiting in line and being rendered slowly. Not ideal for graphics. Now, the cores in a graphics processing unit, being simple but very numerous, are perfect for this task. So in summary, a CPU can do 8 really complicated things at once, while a GPU can do thousands of very simple things at once. Think of one person with 2 big strong arms and another person with 10 very weak arms. If you needed 2 big heavy things lifted, the guy with 2 arms is best for that task. But if you need 10 lightweight things lifted, someone with 10 weak arms is better. The ability to do a bunch of calculations quickly is particularly important for the rendering of three-dimensional worlds. When computers create 3D worlds, they use something called vector graphics. This means they plot out the coordinates on a three-dimensional graph and then draw lines in between them based off mathematical calculations, similar to what you likely did in geometry class. Every object and shape really just comes down to that. Where are these points in relation to each other, and what is the curvature of the line between them? That all just comes down to math, doing a whole bunch of calculations really quickly. This is also why graphics cards are so useful in the process of acquiring cryptocurrency. The type of calculations needed to participate in what's known as Bitcoin mining are far more suited to a bunch of small cores than a few very powerful ones. Now, because your graphics card is like its own computer, it not only has its own CPU, but it also has its own RAM. This is often referred to as video RAM or VRAM. And like with your computer's primary RAM, the RAM in your graphics card stores small amounts of very easily accessible data. In the image creation process, some types of data are very important and need to be used regularly, so the RAM in your graphics card stores that data and sends it to the GPU as needed. So those are the basics of why and how a graphics card does what it does. If you want to know more about the topic of graphics cards, liking, subscribing, and commenting are a great way to let me know that this video is of interest. As always, thank you for watching, and I hope I helped.